Hello everyone. Today here we are again with another session. So in today's session we'll be discussing about Canary release using Istio and Argo rollouts. Like how we can progressively deliver or switch to a new version when we are using Istio. Uh, So there we can get help from Argo rollouts. We'll be seeing how it works and all. So let's get started without any further delay. So in today's agenda, we'll be seeing like why Canary? Why do we really need Canary? And what it is exactly. Then we'll be going about like how Istio does the traffic splitting. So with the help of Istio, we can granularly control the traffic split between the services and different versions and all. Like if we don't have Istio in usual cases, what happens? Like Kubernetes plain case, it the traffic is distributed based on the number of pods of the versions. But Istio has control. It can control even if we have less number of pods or the more number of pods, we can control the traffic granularly, like what percentage of the request should go to which version. Then we'll be discussing about mechanism of Istio and so integration mainly Istio and Argo rollouts, how to integrate them and how to make use of both. Then we'll be seeing like Argo rollouts, what all the options we have, what are the things we can do with that. And at the end, we'll be seeing HPA, a very small thing in HPA, horizontal pod autoscaler for Argo rollouts. We'll be touching very minimal part of it. And in the future, we'll be covering more like how we can handle that based on the matrices and all. Okay, so here we are. Why Canary? So let's first understand what is Canary. So what happens when we have application deployed into the production and we are releasing new features or fixing the bugs. So we cannot take down everything, whatever it's there in the production and then relaunch the new version. So what happens in that? Side by side, we deploy both. So production, whatever it's going on, it will continue to get traffic. We deploy the new version, which is having new features or fixes, and we try to allow some percentage of the traffic to go to the new version and see the behavior, like how it works. And based on the feedback, based on how it is, whether it's stable, not stable, we gradually increase the traffic to, to the new version. So the first point, it says gradual release to the production, like as I mentioned earlier. So like we are shifting the traffic towards the new version gradually. Okay. And then we have zero production downtime with the faster rollback. It means we have when we have something to like something goes wrong, like in the new version, as I said, if it's not stable or something is, we can roll back easily without any production downtime, or and even like we can upgrade also with the zero downtime. Less costly with it is a very less costly solution because it doesn't require any extra other clusters and all to set up. In the same cluster we can set up and all, so less costly with so small infrastructure and all. Flexibility for businesses to experiment with new features, as I mentioned earlier as well. Like if we are having new features we want to release and see the feedback, how the user is behaving and all, that we can allow based on like few percentage of the traffic we can route it and then we can get the feedback. Even we have ability to carry out A/B testing, like different versions if you want to see what version is working well by splitting the traffic. We can all get all those things. Okay, so going to the next part of it. So how the Istio exactly does the traffic splitting? Okay, so we can see in the first step, all the 100% of the traffic is going to the baseline, like the baseline version. We can have multiple versions and we can distribute the traffic based on the configuration. How and all we'll see how it is distributed. We can have a Canary version and that will get like 5%. Gradually we are increasing the traffic to the new version. Okay, so that way it works usually. But this is a manual process. Like if we don't have any automation and all, we need to check, like we need to go and update the configuration to shift the traffic slowly based on like once we deploy, we see the behavior, we analyze, but this process is manual, it's not automated. So sometimes it might be time consuming because it requires a manual effort and human intervention. To simplify that process, we can have Argo rollouts integration with Istio. So how it simplifies, so whatever once it is configuration is applied and we want to test the new feature, new behavior, just we need to deploy the new feature and Argo rollouts takes care of that. So it shifts the traffic based on the configuration which we have already done in the past. Okay, so either it will shift like few percentage and wait for the manual intervention, like and we want to go and check the matrices, analyze and further promote to go to the higher level of it. It's like gradually shift more traffic to the new version that can be done, or even with the custom configure like matrices and all, it can take the decision and it can promote automatically. So that is configurable. So here it's one of the example. So here we can see we have like pods of version 1 and this is another this showing the same pod just to make sure like 90% and 5%, suppose 5% is going to the each pod, something like that it is. But even as I mentioned earlier, we can control that behavior. Okay. So here is version 1 getting, and when we deployed version 2, which is Canary version, we can control the traffic to 5%. So automatically, like it is going to Istio. Istio can send the traffic to like which version, how many percentage and all. And we can control this behavior of shifting the traffic using Argo rollouts controller. So we need to deploy a Argo rollout and that takes care of the remaining part. No need to have like gradual shifting manually going and editing this one. So in we can use Argo rollouts in two ways. Okay, so to showcase that one, I'll be sharing direct configuration of Istio and rollouts. Okay, so we have two options mainly. So either we can go with workload reference or we can go with the template. So any one of them usually we use. So what's the difference between these two? When we have already, like when we are not new, like we have already deployments and all, it's already in production and we want to try out or we want to start out with the Argo rollouts. That time we'll have deployments already deployed and we can use the existing deployments to integrate or use existing deployments to be used by the Argo. So that's where we use workload references. It means if you are existing user deployments and all it's there already and we want to get started with Argo rollouts, that time this will help. If we are a new user, like directly we want to get started with Argo rollouts only, that time we can have this template. So instead of managing a separate deployments, we can have directly. So it is deployment templates, whatever it's similar to that, whatever goes inside the deployment template. Here it's a similar specification. We can take it from here, paste it here, or vice versa. It's possible, but any one of them should be there. Okay. Okay, I'm back to the Argo rollouts. Let me get back to PPT. Okay. So here we have for, as I was mentioning, new users. So new users can directly get started with the template if we don't want to maintain a separate deployment that can be handled directly using the Argo rollouts itself. Okay. And if we are a new existing user, like we have already deployments and all, that time we can use deployments. And we can configure Argo rollouts to take over that replica set and all. So it will basically it will read the deployment and then configure Argo rollouts to control all those behavior. Okay. And even like we have multiple options. Either we can get started with template in the rollout CRD, or we can get use of the deployment in Argo rollout, or we can shift from either here to here based on our need. So it's flexible based on our things need to be done. But yeah, one thing to note, as we if we use deployments, definitely we will have some replicas and all. But when Argo takes care of that replicas, so we need to make replicas of the original deployment to 0 so that Argo all the things is controlled by Argo. So we need not need of any replicas of the deployments. That's where we make it 0. I'll be showing in the demo. Okay, so Canary implementation using Argo rollouts. That's a demo we'll be doing, like what all the things Istio and Argo, how it integrates, and then we'll be seeing how to integrate HPA for Argo rollouts. Okay, so let's get started with the demo. Okay, so first thing first, to integrate, I have already prerequisite was Istio, or as I have already Istio installed. Okay, that we need to make sure Istio is there. I'll be starting with Argo rollouts installation. Okay, so it's very simple. Just create one, like whichever namespace of your choice, and we can apply this configuration directly. It will install Argo controller. Okay, so let's wait a few seconds. Fine. So we can check also if it is up and running. kubectl get pods Argo rollouts. Okay, we have controller running already, so we are good to go. And let me check if we have what are the namespaces. kubectl get. Okay, Istio Argo rollouts. Let me check if I have created this one like namespace for our demo. It is Istio enabled. We should be using this one so that all Istio features and all it works. Okay. So to verify that, kubectl. Let me check if nothing is there. It's all clear. Get all. And then Istio Argo rollouts. Nothing is there. Okay. Here also we'll have two options, as if we are familiar with Istio. Virtual service is capable of doing traffic split. So we can have two different services and single or multiple virtual service, so that we can send the traffic to two different services altogether. And the second option is we can have service will be single, and we can use destination rule to split the traffic. we'll be seeing both today. I'll be showing both the cases how. So let's get started with multiple service and single virtual service that will be seen. And as I was mentioning the first part, like options, I'll be showing that both options also, like in the rollout itself, we are giving deployment options, and either we can use the deployment CRD itself. Okay, so I'll be showing both the cases. I'm removing this one so that I can showcase how it is working. Okay, why it's sometimes not working. Okay, my keyboard is having some issues. Sorry for that. Okay, so let's get started with gateway deployment. So I'll try to deploy a gateway so that we can get traffic and all, and we should be able to see live like what is happening. I've already created namespace we saw, and it's Istio enabled here. I'll be deploying gateway. So kubectl apply gateway. Okay, it's already applied. We'll be using the IP to access it. Currently, if we try to use, nothing will be visible. Get SVC, Istio system. Okay, so this is external IP. We'll be using this one to check the traffic and all how it is working. So let me open. Oh yeah. Oh, sorry. It didn't copy. Because there's nothing like virtual service and all is not configured, so we'll be seeing 404. But it's not accessible and all currently. Gateway is up. Okay, we'll be starting with multiple service. Single, like we can see here, we have two services. Rollouts demo stable, rollouts demo Canary. We have two services we have, and currently we are pointing to selector, like we are having same selector, and these selectors will be updated by the Argo when we use this one. So for Canary, for stable, that will get modified by the Argo rollouts automatically. We don't need to do anything. Okay, so let's get started with. So first we'll deploy services, and then we can have VS. Okay, and we can have rollouts. So let's get into this folder. CD single VS, multiple SVC. Okay. kubectl services. Let me deploy. So it will deploy to services. Okay. We can see we have stable, Canary, two services are there. Okay. And then we'll deploy virtual service. So here we can see like stable one, we are having 100% weight at the beginning. Canary one is having 0%. When we change something, it should automatically get reflected. So what happens? Argo rollouts modifies this weight automatically, as I was mentioning earlier. We'll be seeing that one how it works. So let's deploy this. Apply. So virtual service applied. Okay. Then we'll deploy rollouts. Okay. So keeps it here. Let's see. Nothing is running. If any rollouts and all. No, nothing. So let's deploy this. kubectl -f rollout. This option I am showing with the template option directly embedding the container information into the rollouts CRD itself. Okay, instead of having separate deployment. So for new users, it might be easy to maintain one CRD and get started. Okay, it is created. Let's see what happens here. Yeah, so we can see we are having one pod running default. I have here it's replica one. That's why it is we are seeing if we try to increase the replica, it will create more. So let's try to have two replicas. Okay, and let's see what's the behavior. We have two replicas running. Okay, version one stable, it's telling blue version and all. Now it's time to test the Canary behavior. Like when we have new feature, what are the things it does? So we can see all the traffic is going to stable, and when we try to access it, it should be here. Okay, so let's try to access it from here. Yeah, so we can see all blue because it's only one deployment and only one version is there, blue. Okay, and we are getting all blue. Okay, now it's time to change and see the behavior for how it is behaving. So we have set the rule as 20%. So initially it will set the traffic to 20% to the new version, and it will pause until unless we promote. We can have different criteria here. And once I promote, then it will go to 40, then wait for 10 seconds, then go to 60. Gradually it will change. But here it will wait for manual intervention. We can do even like we can have some other criteria as well. So that's will be covered in the future. But for today's, we'll be seeing this one. So I'm updating now the image to new one. So suppose it's another image I added. Okay, I deploy and see. Let's see the behavior how it is working. Yellow. Okay, configured. Let's go here and see. So it started another one, Canary. So we are having two versions here. We can see stable one was the blue, and then we have yellow Canary version. So we can see here two pods and one pod got created, and some traffic definitely it should go to this as well, the Canary version. Let's check how the virtual service is looking like now. kubectl get vs ns istio argo rollouts. Yeah, as I was mentioning earlier, initially when we had deployed it was 100 and 0. So now we can see it got automatically updated to 20 because we have wrote that way, like shift the traffic 20% and wait there. So it is waiting, and we should be able to see yellows as well. So we can see blue are more and yellow are lesser. So 20% it's having three pods, but still like 20% of the traffic only is going to yellow. Okay, we can see like 80% of the traffic is coming from the blue. Still, like if it would have been a kind of older thing and all, like without Istio, then three pods means 33, 33, 33. It would have been 33%. But here we can control that behavior. Okay, so that we saw, and it's working. So now it's time to promote. So we'll be promoting and making that Canary as go like it will shift the traffic slowly 40, then 60, then 80, then 100, and then at the end it will become that canary will become the stable one. Okay, so now we need to fire a command to promote that. So let's go to the terminal and fire the command to promote that one. Okay, so we need to fire kubectl argo rollouts promote rollout name. Rollouts demo is the name and namespace. So it's Istio Argo Rollouts. Okay, as soon as I promote, it will start shifting, creating the new pods and shifting the traffic from here to here. Okay, so we can see here it is creating the new pod into the canary. Okay, so we have two pods here. Now this will scale down the stable one, and this will become like now this shifting the traffic. We should be seeing that here. See, now more yellows, blue are less, and slowly that blue will go away. Only yellow should come as all the traffic gets shifted to the yellow one. Okay, let's check. Yeah, so we can see now this the yellow has become the stable, and that's why we are getting only yellow here, because all the traffic is getting solved by the new version. Okay, and this one will be scaling down, so it's not terminating. If this although existing the previous version will be removed. Okay, so that was the case one when we use multiple services. Okay, now I'll be showing the case two in which we can use destination rule with single service and how it works. Plus, I'll be showing how the existing deployments can be used in this case. Okay, so for now, I'll be removing this one, clean up, and then again I'll start with this second thing. Okay, so kubectl delete nif dot. Let's remove everything. Okay, here also should be removed. Yeah, done. And nothing should be there. Fine. So now it's time to go to the test second option. Okay, so now we are not getting anything. Okay, because that everything got removed. So let's go to the other option here. So here I have deployment, separate deployment, destination rule I'll be using, Canary and stable. I'll be using rollout with deployment option as I was mentioning. Here is the option. We need not to change anything in the deployment. Existing deployment can be used. So this will be very useful for the users who are using deployments already, and they want to automate their uh, traffic shifting process to the new version. So this is very helpful. So this is that option here we can do. Then I have single service, unlike the previous one, which was having two services, and I have one virtual service and subset extending to stable and canary weight 0, and at the beginning it's 100. Okay, so we'll be doing similar kind of thing again, but with the same one single service and multiple. So here we have destination rule. So let's get started with this and see how it works, whether it's working the same way or not. So I'll be deploying deployment first. Okay, so kubectl apply ifnf deployment. I'll deploy a service, virtual service, and at the end I'll try to deploy, or rather I'll deploy the rollout. Okay, So deployment created. Now it should have 5 replicas. We'll verify that. Kubectl -f service, let's deploy service. Then we'll deploy virtual service and destination rule. Kubectl apply. So it's a virtual service. Okay, and let's deploy our destination rule. Kubectl apply and rule destination rule. Okay. So with this, we should be able to get things working. Okay, we should be able to get the traffic, at least the existing ones. Here we are seeing the replicas. So let's check that how it looks like currently. Get pods. Sorry. Here. So these are the pods not managed by Argo rollouts. These are the deployments one. Okay. When we deploy Argo, that takes care of that, and we need to scale down all these things. Okay. So let's check. Okay. So this is the existing one. Currently, Argo rollout is not in place. Okay, we are seeing all the blue traffic here coming out from all those 5 pods and all. Okay, now we'll be deploying the Argo. So Argo, once we deploy the Argo rollouts, it will create its own pods. So it maintains its own replica set to manage the Canary and all. So we'll be seeing that behavior. Kubectl apply -f. Now it's time to apply. Okay, let's see what's happening. We can see here rollout. So these are managed by the Argo rollouts. These are the older ones. So I'll be now scaling down this, and still we should be able to see the things working. Okay, I'm making it 0, and I'll apply that. Okay, configured. So let's check. Now it's terminating. Everything is here terminating, but still we should be able to see like our application working because we have a new set of pods running managed by Argo rollouts. Okay, we are seeing here. Let me refresh. Yeah, it's working. We are getting. So no downtime. So it works. So we do not have to anything like pause or do anything. When we have Argo rollouts in place, it creates its own pods, and when it's up and running, we can go ahead and scale down the existing ones, and the application will be still running. So zero downtime. Now let's check once everything okay, all remote. Now these are managed by Argo rollouts. Let's see how it is looking here. Okay, so we have stable version, 5 replicas, stable. Blue one is running. Okay, now I'll go and change to the new version. Okay, so here I came. I'll be changing to yellow or maybe red this time. And let's see what's happening. Okay, need not to change anything. Only deployment, go change, update the new version. And we have the rule again here, same. Pause, it will wait for 20 and do the remaining part of this. Okay, so similar kind of concept I'll again do so that we will be able to see the behavior, how it is behaving. Okay. So now let's go and apply the deployment. Okay, deployment done. Here Canary created, one pod created. So we have set 20% of the traffic to go here. Let's see if we are getting. Yeah, we're getting from the red. So 20% of the traffic now it is getting served by the Canary red version. Okay, let's go ahead and see how it is behaving now. So we'll see get pods. Let's analyze few things. 20% which of service has been updated here. Okay, so we are seeing still service name is still the same here, but we are using subset, so we'll have this one. So it modifies the destination rule to have its manage the different versions. So let's check destination rule. So we can see here it has added new label here. It manages that one, and we can see here this has in the pods we will be seeing. So we can see that we come here. So Canary one is having 6, starting with 6. Okay, 6 one is the Canary one pod we were seeing here. One pod is running here, the 6 one. Okay, and the existing one are the stable ones. Okay, so this way it manages. Now let's go and promote and see the behavior, how it works. So now I'm promoting. See, now new pods are getting created. It will wait and we should be seeing slowly increasing the red. And at the end, all blue will go down, will be removed. Okay, let me make it small so that we see the progress. Slowly it's shifting. Pod initializing, we have 4 pods. It will wait for again 10 seconds and create one more, total 5. Yeah. Once it is up, it will be now coming from all red. Okay. And now we'll be seeing that it is scaling down the previous version. So now the red has become the stable one and the Canary and the older one, blue, will be now terminated. Okay, so we can see now it is terminating and we are seeing all red. It means all the new versions now it's coming. We are getting the traffic from all the new versions. Okay, so this successfully shows like how to integrate with Istio, how Istio and Argo rollouts work together, and we can see how it has simplified the process of Canary. Like we didn't do anything extra, go and update your CRD, only one deployment. So whenever like just image I changed. So with the new application now it's deployed and everything is now taken care by Argo rollouts. Okay, so that's all for the application things, Argo rollouts and all. I'll be showing one HPA as well as I was mentioning. HPA for Argo rollouts. So in the deployment case, we use HPA as well to manage the deployments. Here, in case of Argo rollouts, we apply HPA for the Argo rollouts, and that time when we have a load, Argo rollouts takes care of increasing the replicas. Like Argo rollouts, it will like HPA will takes care of increasing the replica for the Argo rollouts. Okay, managed by like pods managed by the Argo rollouts. Let's see in action how it works. Okay, so rollout HPA. So we need to give target which one to scale. So here we can see Argo rollouts this one. We need to give name. Kind is rollout and rollout demo. So it should be matching with this one name. Okay. And once we apply here, currently I have kept it low. If it is greater than, like if the load is increasing to 10%, more than 10% and all, then it will try, and it is having minimum replicas is 2. Okay, and maximum it can go up to 6. Okay, so let's do one thing. Let me try to first bring this replica down so that we see how HPA in action. Okay, so I made it one here first. Let me deploy. Okay, now let's see what is happening here. It should be terminating and it should be keeping only one replica. All other thing will be terminated. Okay, still we'll be seeing this one. It's coming, working fine. Okay, now we'll apply HPA. So HPA we have configured if it is minimum, it should be 2. So as soon as this is getting applied, that 1 should become 2. And target percentage, if the traffic is increasing more than 10%, then it should go up to 6. That will be thing. We will be load testing a bit. We'll try to increase the load and we'll see how it is increasing. So let's apply kubectl by rollout HPA. Okay, created. Now we should be seeing that behavior. It is managed by HPA to create minimum of 2. Okay, so we can see here another pod got created into the same replica set. Okay, so now we have 2 minimum, and as it is having less traffic, it is not kind of going up, but yeah, once we start to have firing more requests and all, we should be seeing this going up. Now it's time to see HPA in action. So what we'll do, we'll try to increase the load and we'll be seeing how the pods are getting increased, like how the replicas are getting created with the HPA. So let's go ahead and see what's the current percentage. So if we see HPA is currently 3% load, minimum pod 2, which we saw, it's at 2. Okay, max is 6. Let's try to increase the load and see the behavior. Okay. So this will be just firing the request again and again. So it increases the load. Let's see, 14% it has reached. Okay. So now we can see new pod got created, third pod, to handle the load. Okay, so it has gone to 16%. Current 3 replicas are there. Let's see. So definitely HPA is working based on the load. When load is increasing, it is creating the replicas like to handle the load as we have configured. And we have configured currently only for the CPU. We can have different matrices to handle and see what all the things it can do. But yeah, currently it is based on the CPU percentage utilization, and hence it is doing the job. We can have even custom matrices and all to configure the custom behaviors that we'll be covering in future sessions. But this is all for today's. So we saw Canary implementation using Argo Rollouts and Istio. We saw HPA for Argo Rollouts. We saw. That's all for today. If you have any question at any point of time, please feel free to contact us at contact@ms.ai. Thank you.